Good afternoon, students. So today we are going to discuss the nuclei topic. So nuclei topic ಮತ್ತೆ atoms topics MCQs simultaneously check ಮಾಡೋಣ. So in this nuclei topic, we are going to discuss about the some of the properties regarding the nucleus. So atomic mass unit, how it can be measured, size of the nucleus, radius of the nucleus. Then we have different forms of the nuclei, that all we are discussing here. Here we have the laws related to the nuclei, that is radioactive law, we can say it. So let us see first in this chapter, that is nuclei meaning. That is, in every atom, the positive charge and mass are densely concentrated at the center of the atom, and that is called as the nucleus. Here, more than 99.9% of the mass of the atom is concentrated in the nucleus. So here, how the mass of the nucleus can be measured. So idenagatte nucleus mass, it is very very smaller amount. So kg allella helikagalla. For that reason, the atomic masses are measured in terms of the unit called as atomic mass unit anta heltivi. So that is called as what? AMU. So it is called as AMU. So let us see here. What is AMU? It is nothing but the unit to express the atomic masses is called as the atomic mass unit. Why we are using this AMU? Because kg ಮತ್ತೆ ಬೇರೆ ಯಾವ್ದಾದ್ರು mass unit ಏನಾಗುತ್ತೆ ಅಂತಂದ್ರೆ it will be a larger unit. So we require a small unit to measure this. It is nothing but AMU ಅಂತ ಹೇಳ್ತಾರೆ. So ಇದು AMU ಅನ್ನ ಯಾವ ರೀತಿಯಾಗಿ ಎಕ್ಸ್ಪ್ರೆಸ್ ಮಾಡಬಹುದು ಅಂತಂದ್ರೆ it is the 1/12th mass of the carbon atom. So carbon atom 1/12th mass ಅನ್ನ ನಾವು ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ರೆ that is considered as 1 AMU ಅಂತ ಹೇಳ್ತಾರೆ. Here this 1 AMU, it is also expressed as, that is 1 AMU is equal to 1.66 to 10 to the power of minus 27 kg. Nothing but 1 AMU to mass conversion ಅಂತ ಹೇಳ್ಬೋದು. 1 AMU is equal to 6 into 10 to minus 27 kg. Okay. Here 1 AMU can be also expressed in terms of the electron volt. The conversion factor is 931 mega electron volt. Mega andre 10 to the power of plus 6 anta agutte. Mega andre 10 to the power of plus 6. Okay. Here this is the relation between 1 AMU to mega electron volt. ಮತ್ತೆ ಇಲ್ಲಿ ಮೇಲ್ಗಡೆ ಏನು ಕೊಟ್ಟಿದ್ದಾರೆ 1 AMU to kg relation. Now here we are going to discuss the composition of the nucleus. So in the nucleus, as we know that we have the positive charge and the that's called as the protons. Matra neutrons irutte. These are the constituents of the nucleus anta helbodu. The electrons are revolving around the nucleus. Hauda? So electron enagta ide nucleus surrounding alli move agta ide, and whatever the protons and neutrons are, those are the center of the nucleus. Okay. So ಇದನ್ನ ಟುಗೆದರ್ ಆಗಿ ಏನಂತ ಹೇಳ್ಬೋದು ಅಂದ್ರೆ ನ್ಯೂಕ್ಲಿಯಾನ್ಸ್ ಅಂತ ಹೇಳ್ತಾರೆ. It is called as the nucleons. Okay. So what do you mean by nucleons? Is nothing but the protons and the what is that is protons and neutrons together. It is called as what? Neutrions anta heltare. Here we have some of the definitions, like what do you mean by atomic number, what do you mean by mass number. Let us see. Atomic number is nothing but it is the number of protons present inside the nucleus of an atom of the element is called as what? Atomic number. So atomic number andre atomic number ಇದನ್ನ ನಾವು ಯಾವ ರೀತಿಯಾಗಿ ಡಿಫೈನ್ ಮಾಡ್ತೀವಿ? So ನಮ್ಮ ಹತ್ರ ಎಷ್ಟು ಪಾಸಿಟಿವ್ ಚಾರ್ಜಸ್ ಇದೆ ಅಥವಾ how many number of protons we have, that is called as what? Atomic number, and it is denoted by the letter Z here. So ಅದನ್ನ Z ಇಂದ ಡಿನೋಟ್ ಮಾಡ್ತಾರೆ. Similarly, we are defining the mass number. What is mass number? See, so mass number is nothing but it is the total number of protons and neutrons inside the atomic nucleus is called as what? Mass number. Okay. So we have the atomic number. So protons ಮಾತ್ರ ನಾವು atomic number ಅನ್ನ Z ಇಂದ ಡಿನೋಟ್ ಮಾಡ್ತೀವಿ. ಮಾಸ್ ನಂಬರ್ ಏನಲ್ಲಿ ಏನಾಗುತ್ತೆ ಅಂತಂದ್ರೆ protons ಮತ್ತೆ neutrons ಎರಡು ಇರುತ್ತೆ. Okay. So the protons and the number of neutrons, it is called as what? So protons and the number of neutrons, it is called as the mass number. Okay. So that is given by A is equal to Z plus N. So next we are defining how you can denote any element. Chemistry kuda kaltibodu element ಯಾವ ರೀತಿಯಾಗಿ So how the elements can be represented? Let us see that. The elements can be represented. Consider X as any one element. So this X and how we present it? See. So PPT is visible to you or it is not visible? Okay, I think now it is visible. Yes. So the elements how you can represent. Suppose if you consider X as any element, ಯಾವ ರೀತಿಯಾಗಿ represent ಮಾಡ್ತಾರಂದ್ರೆ this X down we write Z and at the top we write it as A. So Z is called as a number, atomic number. So Z ಅನ್ನ atomic number ಅಂತ ಹೇಳ್ತಾರೆ. That is nothing but the number of protons. Okay. A is nothing but A is called as the mass number. So A is called as the mass number. Yes. So here A is given by, that is A is given by Z plus N. So Z is the atomic number, N is the number of neutrons. Okay. Hope so it is clear to you. This is the representation of the element. So X any element, yeah, element irbodu. So you note element for I'm writing uranium 92-236. So uranium 92-236 ಅಂದಾಗ 92 ಅನ್ನೋದು ಏನಾಗುತ್ತೆ, 92 will be a atomic number and 236 is a mass number. Okay. So like that we can represent any element in the form of atomic number and the mass number ಅಂತ ಹೇಳ್ಬೋದು. Here, before we to discuss the size of the nucleus, we will define some of the terms. Like, what do you mean by isotopes? What do you mean by isotopes? What do you mean by isobars? So that we will define, then we will know the size of the nucleus. Okay. So what we are going to define. What do you mean? So here, what do you mean by isotopes? And what are the example for the isotopes? Let us see. Isotopes, but these are the nuclei having same atomic number but a different mass number. These are the atoms having same atomic number but different mass number is called as what? That is isotope. Okay, so here we can write this one. These are having same atomic number but different mass number, but different mass number. It is called as what? Isotopes. It is called as isotopes. Okay. Now let us see the next one. What are the example for the isotopes? So again, in the exam, sometimes they will ask this point. So what are the example for the isotopes? We can take hydrogen and deuterium. So this is the isotope. You can see same atomic number is there. 1 1 ಇದೆ, ಇದು atomic number ಆಯ್ತು. but different mass number. So ಇಲ್ಲಿ 2 ಮತ್ತೆ 1 in represent ಮಾಡ್ತಾ ಇದೀವಿ. That is nothing but the mass number here. So ಇದನ್ನ ನಾವು ಏನಂತ ಹೇಳ್ತೀವಿ? These are the isotopes of the hydrogen, isotopes of the hydrogen. Okay. So similarly, we can write it for oxygen also. We have many other elements, examples. Now let us define the next term, that is called as the isobars. So what do you mean by isobar here? Isobar means these are having the same mass number. These are having the same mass number, but different atomic number. It is called as the isobars. That is called as the isobars. Here it is represented by H13 and it is helium 2, 3. So see here we have the same mass number, that is 3, 3, but different atomic number is there, that is 1 and 2. Okay, so this is regarding the isobars. Here we have the next one, that is called as the isotones. Okay, so isotones. So what do you mean by isotones? These are the nuclei having same neutron number, but different atomic number. This is called as the isotones. Okay, so here we have the say 3 definitions, important definitions: isobars, isotopes, isotones. So let us see what is the example for the isotones. So for the isotones, we can take the example of hydrogen 1, 3 and helium 2, 4. ಸೊ ಯಾವ ರೀತಿಯಾಗಿ ಇಲ್ಲಿ ನೋಡಿ ಏನ್ ಹೇಳ್ತೀವಿ ಐಸೋಟೋನ್ಸ್ಗೆ? ಐಸೋಟೋನ್ಸ್ ಅಂದ್ರೆ ಸೇಮ್ ನ್ಯೂಟ್ರಾನ್ಸ್ ಇರುತ್ತೆ ಬಟ್ ಡಿಫ್ರೆಂಟ್ ಅಟೋಮಿಕ್ ನಂಬರ್. ಓಕೆ, ಸೊ ಇಲ್ಲಿ ನೋಡ್ಬೋದು ಅಟೋಮಿಕ್ ನಂಬರ್ ಇಲ್ಲಿ 1 ಇದೆ, ಇಲ್ಲಿ 2 ಇದೆ, ಮಾಸ್ ನಂಬರ್ 3 ಇದೆ, 4 ಇದೆ, ಬಟ್ ನ್ಯೂಟ್ರಾನ್ಸ್ ಆರ್ ಸೇಮ್. ಯಾವ ರೀತಿಯಾಗಿ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ತೀವಿ? ಸೊ ಪ್ರಿಯಾಂಕಾ, ನ್ಯೂಟ್ರಾನ್ ಯಾವ ರೀತಿಯಾಗಿ ಮಾಡ್ತೀವಿ? ದಟ್ ಇಸ್ ಅಟೋಮಿಕ್ ನಂಬರ್, ಸಾರಿ, ಮಾಸ್ ನಂಬರ್ minus atomic number is giving you the number of neutrons, correct? So in the hydrogen it is 3 minus 1 is equal to 2, and in case of the helium it is 4 minus 2 is equal to 2. Yes, so you can see the number of neutrons are same in both the case, but the mass number and the atomic number both are different. So this type of substances are called as what? Isotones. So isotopes, isobars, isotones. Along with the example, you need to remember this. Then other than this, in chemistry we'll study like isomers anta study ಮಾಡ್ತೀರಾ. So isomers ಏನಾಗುತ್ತೆ? These are having the same atomic number but same mass number, and the internal structure is also different. That is called as the isomers ಅಂತ ಹೇಳ್ತಾರೆ. ಮಿರರ್ ನ್ಯೂಕ್ಲಿಯೈ ಅಂತ ಕೂಡ ಬರುತ್ತೆ. ಸೊ ಮಿರರ್ ನ್ಯೂಕ್ಲಿಯೈ ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ these are the nuclei having same mass number but with the interchange of proton number and neutron number. So ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ ಅಂತಂದ್ರೆ ಮಿರರ್ ನ್ಯೂಕ್ಲಿಯೈ ಅಲ್ಲಿ they have same mass number but with the interchange of the proton number and the neutron number. So example for that we can see, that is H13 and helium 2, 3. ಇದಕ್ಕೆ example ಅಂದ್ರೆ ಮಿರರ್ ನ್ಯೂಕ್ಲಿಯೈಗೆ example ಆಗುತ್ತೆ. Hope so these all definitions are clear to you. So these are the different types of nuclei: isotopes, isobars, isomers, isotones and mirror nuclei. So for our study we have only 3. That is isotope, isobar and the isotones. Okay, now let us go for the previous point, that is the size of the nucleus. So next, that is size of the nucleus. So see here, the size of the nucleus, we can describe it based on the radius of the nucleus. So the radius of the nucleus is given by R is equal to R naught A into A to the power of 1 raised to 3 by 1 by 3. A raised to 1 by 3. So R is the radius of the nucleus. R naught is the constant value. So our constant value estide anta nodi 1.2 into 10 raised to minus 15 meter into A raised to 1 by 3. Can you tell me what is A here? So what I'm telling you is the size of the nucleus is given by the radius of the nucleus. So radius of the nucleus R is equal to formula ಏನಿದೆ R is equal to R naught A raised to 1 by 3. ಆಯ್ತಾ? ಸೊ R ಇದು ರೇಡಿಯಸ್ ಆಫ್ ದ ನ್ಯೂಕ್ಲಿಯಸ್ ಆಯ್ತು. R naught ಅನ್ನೋದು ಕಾನ್ಸ್ಟಂಟ್ ಇದೆ. A ಅಂದ್ರೆ ಏನು? What is A? Capital A. Yes, it is mass number, correct? So here this is the mass number. A andre cube root of A ide, that you need to simplify and you need to see the value. Then by using this formula you can calculate the radius of the given nuclei. Then the density of the nuclei formula is there. The density of the nuclei is constant and it is independent of the atomic number, sorry, the mass number. For all the nuclei, and density of the nuclear matter is approximately 2.3 into 10 raised to 17 kg per meter cube, which is very large as compared to the ordinary matter. So it's dense. You can see this is also such a big value, that is 2.3 to 10 raised to 27. How the so kg per meter cube. This is the density. You can see the structure of the atom. Now you can see at the center we have the nucleus. Then we have the different orbits. So last orbit that is called as the size of the atom, and its value is 10 raised to minus 10 meter. Then we have the size of the nucleus. You can see at the center. Correct. So this is the how you can show the atom structure. So maybe in chemistry you might have learned this part. Here we have the next point, that is the nuclear density. So see what is nuclear density. Density of nucleus is given nuclear mass upon the nuclear volume. So nuclear mass plus nuclear volume ಗೊತ್ತಿದ್ರೆ ನೀವು nuclear density find out ಮಾಡಬೇಕು. That is by 4 by 3 by R square. So this is how you can calculate the density of the nucleus. So remember the formula which will help us later to calculate the nucleus, different nucleus density. So illon standard value ಕೊಟ್ಟಿದ್ದಾರೆ, that is 2.9 into 10 raised to minus 17. So adra prakara ಕೆಳಗಡೆ illon graph ನೋಡಬಹುದು. It is the graph of radius versus density of the given atom. You can see it is decreasing. The value is decreasing. Okay, so you may not get any question based on the graph, but the nature of the graph you should know. For exam, you can see the density and the radius. The radius is increasing and the density is decreasing. So from the formula also you can see, correct alla? So formula dalli enide nodi, that is rho is equal to m upon 4 by 3 pi r square. So R matte density inversely proportional irodrinda one value is decreasing, the other value will also get decreased. Next point. Before we to go for the radioactivity phenomena, so here we have some definitions like that is nuclear mass. So nuclear mass is given by the mass of the proton plus mass of the neutron. Then radius we have discussed. Then before going to start the radioactivity, here we are discussing nuclear forces. Yes. So see this point, that is the nuclear forces. So what do you mean by nuclear force? Nuclear force is nothing but these are the strong inattractive forces which hold protons and neutrons together tiny nucleus. So I think so in first year you ಗೊತ್ತಿರಬಹುದು 4 fundamental forces ಅನ್ನ ಕಲಿತೀರಾ. In that we have first one is gravitational force, electromagnetic force, then we have weak nuclear force and the strong nuclear force. So here strong nuclear force is nothing but what? That is the force within the nucleus to hold the protons and the neutrons. To hold the protons and the neutrons ಏನ್ force ಇದೆ ಅದನ್ನ ನಾವು nuclear force ಕರಿತೀವಿ. Okay. Here this nuclear force is a very short range force ಅಂತ ಹೇಳ್ಬೋದು. ಅಂದ್ರೆ within the nucleus act ಆಗ್ತಾ ಇದೆ ಅಂದ್ರೆ ಏನ್ ಅರ್ಥ? So within the nucleus act ಆಗ್ತಾ ಇದೆ ಅಂದ್ರೆ it is obvious that it is very a short range force. Okay. So next point is the nuclear force does not depend on the charge of the nucleon. So nucleon ಇದು positively charged ಇದೆಯಾ, negatively charged ಇದೆಯಾ, ಅಥವಾ neutral ಇದೆಯಾ, that is not the matter here. The nuclear force does not depend on the charge of the nucleon, charge of the nucleon. Okay. Then in case of the nuclear forces, here we study for the nucleus two processes called as the nuclear fission and the nuclear fusion. So what do you mean by nuclear fission? See here. So nuclear fission. So fission andre word meaning enagatte breaking. So fission means nothing but what? A nucleus is getting split into two parts. That is called as what? Nuclear fission. Idanna navu enanta heltivi? Nuclear fission anta heltivi. That is the splitting up of the nucleus or the process of breaking up of the heavy nucleus into its light nuclei is called as what? Nuclear fission. So idanna navenanta heltivi? Nuclear fission anta heltivi. Okay. So here in case of the nuclear fission, we are considering only the heavy nucleus. We are considering only the heavy nucleus like after 90. So periodic table alli 90 ನಂತರದಲ್ಲಿ ಯಾವ್ದು ಬರುತ್ತೆ that So here fission is what? Splitting up of the nucleus into its light nuclei is called as a nuclear fission. So ನಾನು ಏನ್ ಹೇಳ್ತಾ ಇದ್ದೆ ಅಂತಂದ್ರೆ periodic table ಅಲ್ಲಿ after 90. So 90 ನಂತರದಲ್ಲಿ ಏನ್ elements ಬರುತ್ತೆ, those are considered as what? That is we can say it as the nuclear fission ಅಂತ ಹೇಳ್ಬೋದು. Okay, that is called as the nuclear fission. Yes. So example, that is uranium is getting split into its constituent nuclei, that is like barium, krypton, ಮತ್ತೆ energy release ಮಾಡುತ್ತೆ, ಮತ್ತೆ neutrons and ಕೂಡ ಇಲ್ಲಿ release ಮಾಡುತ್ತೆ. So that is called as the nuclear fission process. So in nuclear fission ಅಲ್ಲಿ ಮತ್ತೆ ಎರಡು types ಬರುತ್ತೆ, that is the controlled reaction and the uncontrolled chain reaction. So actually ನೀವು nuclear fission reaction ನೋಡಿದಾಗ here the uranium 235 92 is bombarded with the neutron. ಇದೇನ್ ಮಾಡ್ತಿದೆ ಅಂತಂದ್ರೆ 236 92 it is giving this one. Okay. So ಇಲ್ಲೇನಾಗತ್ತೆ ಅಂತಂದ್ರೆ ನೆಕ್ಸ್ಟ್ ಇದು ಅನ್ಸ್ಟೇಬಲ್ ಆಗಿ ಇಲ್ಲಿ ಕಾನ್ಸ್ಟಿಟ್ಯೂಯೆಂಟ್ ನ್ಯೂಕ್ಲಿಯಸ್ ಕೊಡುತ್ತೆ, that is like barium ಕೊಡುತ್ತೆ, krypton will be there, then along with that 3 neutrons will be there. Okay. So again these 3 neutrons will get hit with the uranium nucleus. Again here it will give 3, again here it will give 3, again here it will give 3 neutrons. So ಮತ್ತೆ ಇದೇನಾಗುತ್ತೆ, uranium hit ಆಗುತ್ತೆ. ಇದೇ ರೀತಿ process continue ಆದ್ರೆ this is called as the chain reaction, uncontrolled chain reaction. Suppose if you are stopping this reaction somewhere here only, then it is called as the controlled chain reaction ಅಂತ ಹೇಳ್ಬೋದು. Okay, so this is regarding the that is nuclear force, nuclear fission. Then the second one is nuclear fusion. So what do you mean by fusion? So fusion ಅಂದ್ರೆ ಏನಾಗುತ್ತೆ, ಕಂಬೈನ್ ಆಗ್ತಾ ಇದೆ ಅಂತ ಅರ್ಥ. So fission ಅಲ್ಲಿ ಏನಾಗ್ತಾ ಇತ್ತು, heavy nucleus is getting split into the 2 nuclei. In case of the fusion here Small nuclei is combining to form a big nuclei. So this is called as the nuclear fusion. Okay, so nuclear fission, nuclear fusion. So in case of the nuclear fusion reaction, light nuclei like hydrogen elements, andre idu sun alagate, this kind of process taking place in the sun. So there the small nuclei combine together to give the heavy nucleus is called as the nuclear fusion reaction. Okay, here in this case we will study one point that is called as the mass defect anta kalitivi. So what do you mean by mass defect? It is denoted by the letter delta m. So mass defect andrenu? Mass defect anta andre it is the difference in the masses of the constituent of nucleus and the mass of the nucleus. Andre ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ ಅಂತಂದ್ರೆ ನ್ಯೂಕ್ಲಿಯಸ್ ಕನ್ಸ್ಟಿಟ್ಯೂಯೆಂಟ್ಸ್ ಏನ್ ಬರುತ್ತೆ ಹೇಳಿ? ಪ್ರೋಟಾನ್ಸ್ ಮತ್ತೆ ನ್ಯೂಟ್ರಾನ್ಸ್. ಹೌದಾ? ಸೊ ಪ್ರೋಟಾನ್ಸ್ ಮತ್ತೆ ನ್ಯೂಟ್ರಾನ್ಸ್ ಕನ್ಸ್ಟಿಟ್ಯೂಯೆಂಟ್ಸ್ ಆಫ್ ದ ನ್ಯೂಕ್ಲಿಯಸ್. ನೀವು ಪ್ರೋಟಾನ್ಸ್ ಮತ್ತೆ ನ್ಯೂಟ್ರಾನ್ಸ್ ಮಾಸ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿದ್ರೆ ಇದ್ರ ಮಾಸ್ ವ್ಯಾಲ್ಯೂ ಮತ್ತೆ ಎಂಟೈರ್ ನ್ಯೂಕ್ಲಿಯಸ್ ಮಾಸ್ ವ್ಯಾಲ್ಯೂ there will be slight variation. So ಸ್ವಲ್ಪ ಇಲ್ಲಿ ಡಿಫರೆನ್ಸ್ ಬರುತ್ತೆ. So that difference in the mass is called as what? Mass defect ಅಂತ ಹೇಳ್ತಾರೆ. It is the difference in the mass of the constituents of nucleus and the mass of the nucleus is called as the mass defect. So this mass defect is given by, it is delta m is equal to z into mp plus a minus z into mn minus m. Last m irodeniದೆ mass of the nucleus. It is the mass of the nucleus. ಮತ್ತೆ ಇಲ್ಲೇನ್ ಫಸ್ಟ್ ಟರ್ಮ್ ನೋಡ್ತಾ ಇದ್ದೀರಾ? ದಿಸ್ ಫಸ್ಟ್ ಟರ್ಮ್ ಈಸ್ ನಥಿಂಗ್ ಬಟ್ ದ ಮಾಸ್ ಆಫ್ ದ ಪ್ರೋಟಾನ್ ಅಂಡ್ ದ ಮಾಸ್ ಆಫ್ ದ ನ್ಯೂಟ್ರಾನ್. ಅರ್ಥ ಆಗ್ತಾ ಇದೆಯಾ? ಸೊ ದಿಸ್ ಇಸ್ ಮಾಸ್ ಡಿಫೆಕ್ಟ್. ಸೊ ವಾಟ್ ಇಸ್ ಮಾಸ್ ಡಿಫೆಕ್ಟ್ ಹಿಯರ್ ಪ್ರಿಯಾಂಕಾ? ದ ಡಿಫರೆನ್ಸ್ ಇನ್ ದ ಮಾಸ್ ಆಫ್ ದ nucleus and its constituent particles is called as the mass defect. So constituent particles andre protons ಮತ್ತೆ neutrons ಬರುತ್ತೆ. So mass of the proton is given by z into mp plus mass of the neutron is given by a minus z into mn. So ಇದನ್ನ add ಮಾಡ್ಕೊಂಡು ಇಲ್ಲಿ mass of the nucleus ಇಂದ ನೀವು subtract ಮಾಡಿದಾಗ ಏನ್ mass difference ಸಿಗುತ್ತೆ, that is called as the mass defect. Okay, is any doubt is there? Nuclear forces, nuclear fission, nuclear fusion and the mass defect. Okay, yes. Is that is the nuclear binding energy. So radioactivity at the end we are discussing nuclear binding energy. So what do you mean by nuclear binding energy? Nuclear binding energy is defined as it is the minimum energy. So idenide idu minimum energy ide which is required to break the nucleus into its constituents. This minimum energy is called as what? Nuclear binding energy anta ಹೇಳ್ತಾರೆ. It is called as the nuclear energy. Okay. Next point. Okay, now we will see what all it is remaining. So related to radioactivity we have here now. So let us see some points. Then after that in the next class we can continue. Yes. So here we are discussing what do you mean by radioactive decay. So Becquerel and Curie, Marie Curie and the Marie Curie will give the contribution for this radioactive phenomena. So see what is radioactivity. It is the phenomena of spontaneous disintegration of the nucleus of an atom with emission of one or more radiations like alpha particle, radioactivity. So radioactivity andre enu ಏನಾಗ್ತಾ ಇದೆ? ಸ್ಪಾಂಟಾನಿಯಸ್ ಡಿಸ್ಇಂಟಿಗ್ರೇಷನ್ ಆಫ್ ದ ನ್ಯೂಕ್ಲಿಯಸ್ ಇಸ್ ಟೇಕಿಂಗ್ ಪ್ಲೇಸ್. ಸೊ ಇಲ್ಲಿ ಏನಾಗ್ತಾ ಇದೆ? ನ್ಯೂಕ್ಲಿಯಸ್ ರೇಡಿಯೇಷನ್ಸ್ ಅನ್ನ ಬಿಡ್ತಾ ಇದೆ. ದಟ್ ಫಿನಾಮಿನಾ ಇಸ್ ಕಾಲ್ಡ್ ಆಸ್ ವಾಟ್? ರೇಡಿಯೋ ಆಕ್ಟಿವಿಟಿ. ಸೊ ಎಲ್ಲಾ ಎಲಿಮೆಂಟ್ ಬಿಡಲ್ಲ, ಓನ್ಲಿ ದ ಹೆವಿ ನ್ಯೂಕ್ಲಿಯಸ್ ಮೀನ್ಸ್ ಅಬೌವ್ ದ ಆಲ್ಮೋಸ್ಟ್ ಅಬೌವ್ ದ 90. ಆಯ್ತಾ? ಸೊ ಅದೇನ್ ಮಾಡತ್ತೆ ಅಂತಂದ್ರೆ ಇಟ್ ವಿಲ್ ಎಮಿಟ್ ಸಮ್ ರೇಡಿಯೇಷನ್ಸ್. ಸೊ ಆ ರೇಡಿಯೇಷನ್ಸ್ ಅನ್ನ ಆಲ್ಫಾ ಬೀಟಾ ಗಾಮಾ ಅಂತ ಕೂಡ ನೇಮ್ ಮಾಡ್ತಾರೆ. ಸೊ ಸಚ್ ಟೈಪ್ ಆಫ್ ಫಿನಾಮಿನಾ ಇಸ್ ಕಾಲ್ಡ್ ಆಸ್ ವಾಟ್? ರೇಡಿಯೋ ಆಕ್ಟಿವಿಟಿ. ಸೊ ಹೌ ಯು ಕ್ಯಾನ್ ಡಿಫೈನ್ ದ ರೇಡಿಯೋ ಆಕ್ಟಿವಿಟಿ? The spontaneous disintegration of the nucleus of an atom with emission of one or more radiations like alpha particle, beta particle, and gamma rays is called as the radioactivity. Next is the radioactive decay. So see what is meant by radioactive decay. It is a nuclear transformation process in which the radioactive rays are emitted from the nucleus of the atom. So ಇಲ್ಲಿ ಏನಾಗ್ತಾ ಇದೆ radioactive decay ದಲ್ಲಿ, it is a process in which radioactive rays are emitted from the nucleus of the atom. This process is called as radioactive decay. So ನೀವೇನ್ ಮಾಡ್ಬೋದು ಈ process ಅನ್ನ speed ಜಾಸ್ತಿ ಕೂಡ ಮಾಡ್ಬೋದು. You can decrease the speed also. So you can slow down by the physical or the chemical processes, or you cannot be accelerated, but you can slow down the process. So this is radioactive decay. Then the last point for today's classes, that is radioactive decay law. So what is this radioactive decay law? See. Okay, with formula here only I'll explain you. Here, the number of disintegration. Here, let us see the first statement. What is that? According to this law, the rate of decay of radioactive atoms at any instant is proportional to the number of atoms present at that instant. Antandre, here, during the radioactive process. So, radioactivity and that is here, the number of atoms are getting, or the radiations are coming out from the elements, that is called as the radioactivity. That process is called as the radioactivity. Here, the radioactive decay law, what it is defining, the rate of disintegration. Suppose n ಅನ್ನೋದನ್ನ number of atoms ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ರೆ, rate of disintegration of the atoms ಅನ್ನ ನಾನು dn by dt ಅಂತ ಬರ್ಕೊಳ್ತೀನಿ. ಹೋಪ್ ಸೊ ಮ್ಯಾಥ್ಸ್ ಅಲ್ಲಿ ಕಲ್ತಿರ್ಬೋದು. Okay, so here the rate of disintegration of radioactive substance at any instant, it is directly proportional to the number of atoms present at that time. Number of atoms present at that time. This is called as the radioactive decay law ಅಂತ ಹೇಳ್ತಾರೆ. ಗೊತ್ತಾಗ್ತಾ ಇದೆಯಾ? That is the rate of disintegration. So rate of disintegration ಅಂತ ಅಂದ್ರೆ with respect to time differentiate ಮಾಡ್ತಾ ಇದ್ದೀರಾ ಏನನ್ನ? That is the number of atoms. That is dn by dt is proportional to n naught. So n naught is the number of atoms at that instant. So now what we can do, we can write it as dn by dt is equal to lambda into n naught, or minus lambda into n. So what is minus lambda here? Lambda is the proportionality constant. Idanna decay constant anta karitivi. This lambda is called as decay constant. So il minus sign ಏನು indicate ಮಾಡ್ತಾ ಇದೆ? This negative sign is indicating number of atoms are decreasing with increase in the time. So time ಯಾವ ರೀತಿ increase ಆಗ್ತಾ ಇದೆ, number of atoms ಆವಾಗ decrease ಆಗ್ತಾ ಇದೆ ಅಂತ ಹೇಳ್ಬೋದು. So this radioactive decay. Okay, so if you have any doubt, you can ask. Yes, Priyanka, any doubt is there? Clear? Is it clear? So ಏನೆಲ್ಲ discuss ಮಾಡಿದ್ವಿ ನೋಡಿ. In today's class, we discussed about the first, we discussed the definition, how you can measure the mass of the nucleus, the composition of the nucleus, andre atomic number, mass number, then different types of the nuclei like isotopes, isobars, isotones, mirror nuclei, ಮತ್ತೆ ಅದಕ್ಕೆ example ನೋಡಿದ್ವಿ. Size of the nuclei ಅಲ್ಲಿ, then radius of the nuclei ನೋಡಿದ್ವಿ, density of the nuclei we have seen. Then after that we defined the nuclear forces, nuclear fission, nuclear fusion. Last part is radioactivity. Is it clear? Any doubt is there? Yes. Now only you tell if you have any doubt. Okay. So last few points are remaining. So we can finish it tomorrow and we can start with the MCQs in the tomorrow's class. Okay. So you can keep yourself ready for the next chemistry class. Okay. Thank you, Priyanka.